Hi, my name is Matt Anderson, and this video is about centrifugal compressors, specifically common safety trips. Centrifugal compressors, they compress gas, not liquid. Liquid is incompressible, or is at least assumed to be. And compressors, they have rotational energy, they spin fast, and that's essentially how they make that dynamic head, essentially moving gas from one place to the other, or the potential to do so. They can be driven by a steam turbine or a motor, which would be by electricity. And there's many other types of compressors besides centrifugal. There's reciprocating, rotary screw, axial. For basics of centrifugal compressors, you have the gas inlet going to the suction knockout drum. And in this diagram, the compressor is shown as such with compressed gas out. So a higher discharge pressure, and then the suction pressure would be on the inlet to the compressor. Here I chose to show it represented using a turbine as the drive. So it's connected with a shaft with high pressure steam out and low pressure steam. However, this can also be shown as a motor driven by electricity. So what is a trip? A trip is an automatic shutdown caused by a safety mechanism. And the mechanism usually has set points for shutdown. So for example, a low pressure, high pressure, maybe a low temperature, high temperature. And the goal is to prevent compressor damage. And when you have a catastrophic failure, which you would obviously always want to avoid, that's also a big safety hazard for personnel. 4 types of common compressor trips. There's many more than this, but I just want to go over 4 in this video. 1 is high level in the suction knockout drum. 2 is low loop oil pressure. 3 is high vibration. And 4 is overspeed. And that would be specific for turbine-driven compressors. So for suction knockout drum high level, and this diagram that I showed previously, this is the suction knockout drum. The purpose of it is as the gas comes in, if you have liquid droplets, the droplets literally knock out and start to form a liquid level in the knockout drum. And then that liquid level is pumped or maybe use pressure to send it to another location so it can be processed and maybe recovered if it's hydrocarbon. And so the suction knockout drum, if the level starts to build too high, there's a trip for that because, as I mentioned in the very first slide, compressors, they do a great job compressing liquid. Sorry, they do a great job compressing gas. They do not do well at all compressing liquid, and that will cause serious damage. And so the first trip we're going over is if your suction knockout drum gets a high level, that can just result in tripping the compressor. A lot of compressors have trips set up for that. The second is low lube oil pressure. So this diagram looks pretty complicated, but this is trying to show the lube oil system of a compressor. And so just like a car engine, compressors use lube oil. And so when there's not enough lube oil, damage will occur. Essentially, you'll get metal on metal contact, and which is not designed for it. And so that will result in very rapid damage. And compressor lube oil systems typically have pressure sensors. And the purpose of those pressure sensors is to make sure that you have enough circulation. If the pressure is too low, then the compressor will trip. So in this diagram, you can see PSL, PAL, PE, PSLL, PALL. This is a little bit of a bonus, I guess, engineering. But all those acronyms are pretty common in the process industry, so refining or chemicals. So the first letter when you see something like that is usually the parameter that you're checking. So P would be for pressure, T is temperature, L is level. And so what you'd see for PSL, that would be a pressure switch low. PAL is pressure alarm low. PE, that's a little different. That's the pressure final element, such as a sensor. If you saw a TE, that would be the temperature final element, like a thermocouple. And then PSLL would be pressure switch low low, and PALL pressure alarm low low. Okay, and then high vibration is the third item I want to go over. And vibration would indicate an imbalance, which will cause damage. You can imagine that the compressor spinning at something like 3,600 RPM rotations per minute. Any kind of slight imbalance could result in some serious damage. And so there's multiple probes for both axial and radial vibrations, and we'll go over what those directions mean. And the most common type of vibration probe is the accelerometer. There's other types such as strain gauge or eddy current, but accelerometer is definitely what you're going to see most in industry. So axial vibrations are parallel to the shaft, and that's the direction that the vibrations be in, which means that radial vibrations are perpendicular to the shaft. And then axial vibrations are also known as thrust vibrations when it's moving in that direction. The last trip we're going to go over is overspeed, and that's when the compressor is driven by, specifically if it's driven by a steam turbine. And so steam turbines, they have a design minimum and maximum rotational speed. If you exceed that, that could result in damage, and operating above that, really catastrophic damage is the problem there. And so to prevent that, compressor or turbines have multiple trips that would prevent that from occurring. As a summary, the 4 trips that we went over are high level and suction knockout drum, low lube oil pressure, high vibration, and overspeed for turbine driven compressors. And a reasonable question is, why is this important? And I'll answer that with an example. And so if you can imagine you're working in an oil refinery and you hear a wet gas compressor trips, there's kind of two ways you could respond to that. One would be, I wonder what caused the compressor to trip, and that's all you know about it. A second way would be, I wonder if the wet gas compressor tripped on a high suction knockout drum, or if it tripped on low loop oil pressure or on high vibration. And just by starting that being your starting point, you're already thinking about, what could have caused the trip and starting your troubleshooting process there instead of not even understanding what the potential causes of the trip could be. So something like that, I think in the process industries, it's always important to be trying to learn more, trying to do better, understand more. And this is just one small way that you can do so. So there's a lot more types of trips in this. This is just four of them, but it's a starting point. So good luck in what you're trying to learn. Thanks. How was it? You can be honest.
It was just sometimes I think you're gonna have to like cut off parts where you like stopped and then you messed up and then
Okay.
that part.
Okay. That sounds good. That's fair.